Final section of trigonometric ratios, chapter 9, is the transformations of trigonometric graphs. Trig graphs transform in exactly the same way that any other function does. So it's worth reminding ourselves of what those transformations are. This is GCSE, but probably worth reminding ourselves of what the transformations are. So if we have a function f of x, any function, could be a trig function. If I multiply it by a value, by a constant, then this graph, we're comparing each of these to the original, then this graph is a stretch scale factor a in the y direction. Like I said, this is GCSE knowledge. Look back in GCSE notes if you still have them. You should have some work, some notes, some diagrams for these. Worth spending a little bit of time on this first before you get to trig functions if this is new to you. So if you multiply the function by a value, you're stretching it in the y direction. So this way, up and down by scale factor a, where the x-axis is your anchor. The x-axis, any points on the x-axis don't move. All the other points stretch upwards or downwards, depending on which side of the x-axis they're on. This one, if I'm adding a value to the function, then I'm simply translating it. That's a translation. A places in the y direction. So if a was 7, you simply move the graph up 7 places. If a was -2, you move it down 2 places. The whole graph, you don't stretch it, it doesn't change shape, it just changes position. It's a translation. Notice that these two, where the operation comes outside of the function, are in the y direction. These two, I'm now applying the operation to the function, to the value of x before I apply the function. So I'm multiplying x by a number or adding a number to x and then applying the function. So this one here is a stretch scale factor 1 over a in the x direction. So if a was 2, it would bring it in, it would squash the graph together, scale factor half. This one here, if I'm adding a number to x and then performing the function, this is a translation, let's be consistent with my capitals, this is a translation a places in the x direction. This is the mistake a lot of students make. They move it a places to the right. It's actually minus a places. So if it's a positive value here, it goes in the negative direction. The graph doesn't change shape, it changes its position. It's a translation. Special cases, minus f of x is simply a reflection in the y-axis, and f of minus x is a reflection in the x-axis. Notice once again, if the minus is outside, it's in the y direction. If I'm multiplying on the outside, it's in the y direction. If I'm adding on the outside, it's in the y direction. If the operation is inside the brackets, then it's always in the x direction. Okay, I'm going to have a look at one question which I've just made up, and then we're going to talk very briefly about the connection between sine and cos in relation to these transformations. Let's have a quick look at this. I've got x is between 0 and 270, and I need to sketch the graph of y equals half sine 3x. So I've got two operations here. One is multiplying x by 3 first, then applying the function, which is sine, and then multiplying that by half. So I've got a combination here of this one. So I have a stretch scale factor 1/3 in the x direction for that. And then this one, which is a stretch scale factor a in the y direction. So I need to combine these two on this graph. Okay, a good way to start is to start with our base function sine. So draw sine first. Let's just do a quick sketch of sine. Apologies now for my appalling artwork. $90, 180, 270, that's y equals sine x, and that is 1. I'm now going to do a sketch of sine 3x. Well, 3x is a stretch scale factor of 1/3, so it's squishing this all in by 1/3. So this point is going to go to there. This point is going to go to 1/3 of 180, which is 60. And this point is going to go to 1/3 of 270, which is 90. So it's going to be like that. So this is now y equals sine 3x for values of x from 0 up to 270. And now I need to half that. Well, the half just makes this graph half the size, half the height. So if I use a green pen to distinguish, it's going to be half the height, so it's going to go up to there and down to there, but going through that same point there. So the green line is y is a half sine 3x for values of x between 0 and 270. So deal with the ones next to the x first, and then the ones after the function.